A warm welcome to this session on data science and machine learning using R. It is presented by Machine Analytics. It's a startup which is focused exclusively on data science consultancy and training. We do both data science consultancy as well as training. I am Karthik. I am based out of India, and I have partnered with Raghu, who is based out of US. We have been doing data science training uh, exclusively for US students for the past 8 months. So we had around 3 to 4 batches on R, Python, and data science machine learning using R, Python, etc. So we are quite focused on R, Python, and machine learning. So we don't have plenty of things in our plate. Very focused. And a personal background, I am a data scientist myself with 10 years of experience. Was a data science machine learning researcher with publications, patents in an R&D setup for close to 5 6 years. Then moved to startups, did my consultancy, worked on different domains like IoT, sensor data analytics, and then banking and financial services, retail, CPG, ad tech companies, etc. So my experience has been spread across at least 5 to 6 domains to reasonable depth, and a long career on exclusive on data science and building machine learning models. That's the quick introduction, and the agenda for the day is to get a feel for all these terminologies. So what is data science, machine learning? Why should we even learn data science, machine learning? And what is the job trends looking like? What's the future looking like? And what's the specialty of R in data science? And then we close the more of a monologue of me speaking, and then we will actually do something practical in R, so that whoever has not worked on R, you will get a feel for how this works. And again, we will try doing something on machine learning as well. So that's the agenda for the day. Okay, let's get started with the terminologies. The first thing whoever I encounter speaking about data analytics is the first question they ask is too many terminologies. I just don't understand what is the difference between all these things. I hear data mining, data analytics, data science, machine learning, artificial intelligence, and maybe many more pattern classification, feature engineering, so many jargons around this larger umbrella of data analytics. So what do these mean, and why am I hearing this only in the recent past? I did not hear about this maybe 5 years back. Why am I hearing this so many terminologies in the recent past? What's going on, and what is the reality? So this slide will decipher the world of jargons. Let's trace back on the fundamentals. Mathematics and statistics, we know, has been existing for several centuries, and there were always mathematicians and statisticians who don't worry about practical applications. They just come out with theories and prove that it works, but they don't bother about applying it on any particular uh, business application or any application for that matter. This community has been there for a while, and there were people who were strong in domain. People have been doing business for several centuries. Again, people retail, it did not come in the past 10 years or 15 years. People have been selling things for several centuries. Again, banking in one way or the other has been there for a while. Manufacturing also has been there for several centuries, just that it got automated, several mechanical instruments in the recent past, maybe recent decades. But again, domain knowledge has been also there for a while. People have been taking decisions, people have been running businesses for a while. This merger of using mathematics and statistics for certain applications is called applied mathematics, applied science, or to put it under a larger umbrella, it is called traditional research. People use mathematics and statistics to solve some business problems. This is called traditional research. People who are strong in math statistics coming up with the new structural equations for a civil engineering construction. That comes under a traditional research. People again who use some partial differential equation for solving a problem in a refinery. Again, a traditional research problem using some computational fluid dynamics. So this combination has also been existing for a significant time, at least a few centuries. Let's look at the other side. Computing. This came definitely 4 5 decades before. People have their first computers present doing some kind of computing in a very minimal scale and then using it for business purposes. So having some computing systems and using it for some business purposes also has been there for a while, ever since the first computer was invented. People generally do some programming, even do hacking for that matter, use the computing skills and apply it to a domain and leverage. Let's look at this interesting combination, which is using computing skills and applying mathematics and statistics. There are several computational mathematics, computational statistics, and machine learning is one such child of this marriage, applying mathematics and statistics on computing using the computing environment. For instance, there are a lot of learning algorithms in statistics. What's a learning algorithm? Where you let's look at what is learning according to us. We were taught in the past what is the difference between an apple and an orange. We know the difference between a red and a blue. We know the difference between a triangle and a square. So all these are outcomes of our historical learnings. We were taught in the past, we learned in the past, and in future we are able to take a decision based on our past learning. Can I make a machine learn from past? That is machine learning. For that, you need statistics and you need computing skills. So this combination is machine learning. So you statistically train a computer so that a computer learns and take decisions for future. This is machine learning. Again, machine learning is something which is not very new. It has been again existing for several decades. The earliest adopters being the signal processing community, where most of the statistical and mathematics algorithms which were lying in as publications were implemented in a computing environment and available for larger audience to use. So combination of this and building machine learning algorithms in a usable format has been existing for again 3 to 4 decades. This marriage of machine learning to business applications, this is reasonably new. I would say the wave started in early 2000, where usage of machine learning for solving real world business problems like retail, manufacturing, banking and financial services. All these happened in the recent past, learning algorithms for solving business problems, and that is called data science. Using data for solving business problems is data science. Having some learning algorithms without use for any business purposes is machine learning. Using machine learning to solve problems is called data science. These are the subtle differences between machine learning, data science, etc. Artificial intelligence comes under machine learning. Artificial intelligence is one way of teaching a computer. Instead of teaching statistically, you can teach it like a human being. There are algorithms called neural networks, again come under the branch of machine learning, and it is also a learning algorithm. Data mining, again it was an old terminology for data analytics, and it has its new name now, which is data analytics. So this is the space. So one should be very clear on what is machine learning, what is data science, even before starting to learn it and understand the job space or the industry space for that. Any questions on this particular slide? If someone is good, probably you can type it out in the chat window so that I can move on to the next slide. Maybe one or two goods are fine for me to keep moving. I assume we are good. Let me proceed. Okay. Thanks, Niranjan, for the note. Okay, having got the definitions clear, now let's look at why this is being popular in the recent past. It is getting popular because of the amount of data which we are generating. Every day we create 2.5 quintillion bytes of data. That's so huge. And 90% of the data which is there in the world today has been created in the last 2 years alone. So whatever data we have in the world now, 90% of it is created in just last 2 years, which means we are generating so much of data, and there is a need for analyzing it and making business insights out of it. So the first driver for data science is the amount of data which is available and the associated availability of computing platforms, big data environments, etc. And the next big driver is the business value out of it, because data analytics or data science is not a bubble or something which is still in the academia research but not brought into use. No, it's all old story. People have started realizing business value out of data analytics. Some projections, like in the retail and manufacturing industry itself, they could increase their GDP to 325 billion by 2020. That's the forecast of the growth of retail and manufacturing industry in the US alone, purely by usage of data analytics. Data analytics is intended to drive the GDP of these industries to a significant extent by 2020. There is another forecast which is very interesting. Big data technology itself, be it big data or data analytics, products and services put together, that's growing at a rate of 23.1 percentage compounded annual growth rate. That's actually no other industry is growing at such a rapid rate, and it is expected to become a $50 billion industry by 2090. Which means if someone is part of building data products or doing data analytics services, they are in a great place because they are part of a group which is growing significantly. So much growth from a revenue standpoint, 23% growth is quite big, and that industry itself is going to become a $50 billion worth by 2090. Which means there is a business value, there is a money lying on table by using data analytics. So there is a money lying on table by using data analytics, which the data services and data products company are trying to leverage, and they are also internally growing. So there is a handshake between the business users and the data service providers. And few other sensations which happened in late 2000, around 2008-9. Google did this wonder when there was the swine flu attack in US during that time. Google was able to predict which regions are going to be attacked by flu even before Center of Disease Control was able to predict. Center of Disease Control, as we know, is the authority for forecasting diseases, preempting it, preventing it, etc. in US. But Google was able to do this prediction even before Center of Disease Control was able to do. This created a big sensation in US. And other sensation which has been recently created due to the elections in US. Obama himself used a lot of data science in his second election campaign. And as an outcome of it, he actually created a position called Chief Data Scientist in White House. And the first Chief Data Scientist was an Indian, who is DJ Patil, very famous in the data analytics community. And he was the first US Chief Data Scientist in White House. Let's even take the recent victory of Donald Trump, especially in Arizona. He used data science exhaustively in his campaign, and he was able to win Arizona. We could clearly attribute it to using of data science. And it was an Indian who helped him win this. His name is Avinash. So there is a lot of connect between data science elections one, but the connect which we should be interested to know is the connect between data science and Indians. Across the globe, if you look at top data scientists, they are all from an Indian or by and large an Asian native, because we have this deadly combination of mathematics, statistics and programming. This combination is very rare combination which we naturally have in Asia, especially in India, because India is a strong IT country. Indians are expected to be strong in IT programming, and naturally we are expected to be strong in mathematics, statistics. So this kind of a deadly combination is there with Indians. That's why this world of data analytics is dominated by Indians and Asians to a larger extent. Another big hype which was there around data science because of Google. Google was able to make money using data. As we know, as we type something in Google search, we will have some advertisement here, and this advertisement would actually be customized for each individual, which means let's say you and me are in the same house, we sign in with our IDs and do a Google search of the same terminology. The advertisement which come for you and me will be very different, because Google has data about you and Google has a data about me, and it knows what all I searched in the past, what all did I buy in the past, where did I buy, at what price did I buy. It pretty much know everything we do, because it traces our emails, it traces our search, it traces our clicks, and it will have all this historical data about us, and it prepares this data and pass it to what is called as an ad tech companies. The moment we do a search, this search term along with all our historical information, what all did we buy, where all did we buy, what is our age, where are we searching now from, which location, where all have we visited in the past, where all have we lived in the past, it will have all this information. This entire information is packaged and sent to who are called as ad tech companies. And these ad tech companies have big servers which runs data science and machine learning models. And what they will do is, okay, now I have someone like this characteristics, and I as an ad tech company is doing the ad campaigns for Nike. So can I put an advertisement for this person? If so, at what price should I bid for this price? So what Google will do is, Google will push this to all ad tech companies. There will be several ad tech companies. Google will push this information to all ad tech companies and then say, hey, whoever is the top 3 bidders, I'm going to give the space to you. So you could bid at 10 cents, or you could bid at 20 cents, or you could bid at 50 cents for that particular space. So whoever is the top 3 bidders, if I have 3 space, they will get the space and they could post the advertisement. What these ad tech companies would do is, can I push an advertisement? If so, which product should I put an advertisement? And if I decide to put a product, at what price should I bid? So many decisions happen purely using data science models, because as you know, all this should happen in fraction of second. You can't have a human being sitting here and doing such decisions, because the moment you do a search, this result comes up. So all this data preparation by Google, passing it to ad tech companies doing some predictive analytics and bidding for the space, and this advertisement coming up, all these happens in fractions of seconds, completely driven by data science in the background. And what is Google making out of it? $50 billion from year, and that is 97% of the company's revenue. Phenomenal revenue by using the data which Google has, and that attributes to 97% of the company's revenue. Rest all, Gmail, Google Drive, whatever it gives to it at free of cost, it is all to make this money using sponsored ads. As I told, it's an auction, a pure competition for marketers to win access to consumers. And this competition is competition of models. So the several ad tech companies all having their own machine learning models, and what do? They try to predict the likelihood of responding to an ad. So every customer, they try to predict what is the likelihood for the person to respond to the ad, and what is the right bid for what, how much price should I bid for that space. So all these decisions are taken by the data science models, and they get the space. Okay, this is from a revenue generation standpoint, from a business standpoint. So as there is so much demand for using data analytics, in turn on the other side there is also a lot of demand on the job market. So as you see, this is the job trends in Indeed, little bit old. What you see here is big data, statistical analysis, data mining, data analytics, machine learning, several search terms using two different languages, R and Python. As you could see, a phenomenal growth of job postings with this, both R as well as Python trending. And what you see in the right is something pulled from Google Trends. Blue line being R, green line being Python, and the orange line being SAS. Both R and Python growing significantly because both being open source languages, having a lot of libraries have a lot of libraries for machine learning. So data scientists post job openings with skill set required in R or Python growing significantly, and a same growth for in general analytics and data science also in LinkedIn. Phenomenal growth, and this is expected to grow consistently in the near future as well, and at least for the next 10 to 15 years this is turning out to be the most lucrative and uh, promising career option. We are seeing very evidently that someone with a data science skill set earning even twice than someone with a different IT skill set. A clear skill arbitrage which is created because of data science skills which someone has. What's the upcoming trends? McKinsey has projected that there will be 140,000 to 180,000 data scientist openings by 2018 in US alone. So even just in US, there is an expectation of 140,000 to 180,000 data science openings by 2018. This is huge. There is a clear skill gap. So existing workforce should be able to fill that gap. And even in India, for that matter, NASSCOM recently reported that in India, it is witnessing a eightfold growth, and it is going to become a $16 billion industry from what is being a $2 billion industry. Currently, data analytics is a $2 billion industry in India, and that's going to grow into a $16 billion industry by 2025, eightfold growth, which means there is an eightfold growth in the job openings as well. Job openings to grow at an 800% rate. So if someone who is strong in data science has the knowledge, they generally don't find it hard to have a job which is as high paying as any other job. Someone has a knowledge, they are picked like a hot pick. That's the industry looking like. Before we get into some practical use cases of data science, any questions on why the hype surrounding data analytics, and what is it from a job posting standpoint? Any questions? Okay, I got to note that. It's good. Okay. And anyone has a question, you can feel free to interrupt me at any point in time as we speak. Since there are no questions, let's move on. So where is data science being used? Let's look at it by functions. By marketing. In marketing, churn analysis is one of the most popular data science technique, where a company any B2C company would like to know, is my customer going to leave me? Let's say there is Comcast versus Verizon versus AT&T versus T-Mobile, all these B2C companies. They would like to know what is the probability for each of my customer to leave me. If I can pick customers who have a high likelihood for them to leave me, then I can try calling them, check with them what is the issues they have, if they have any, or try to have some customized discount so that I could retain my customers. This is widely done in the telecom companies. That's why I gave telecom examples. Even in Indian scenario, Airtel, Vodafone, all have a data science team which is working on churn analysis because a highly competitive industry where switching between different competitors, a customer switching between different networks is quite common. So churn analysis is very important in across all industries, especially in telecom. Another use case is customer segmentation. I have 1 million customers. I want to do some promotions. To whom should I target my promotion? So this could be done by doing a customer segmentation. Uber, for an example, me and my wife stay in the same home. Uber sends a promotion to me but not to my wife because Uber has put me in one customer segment and my wife in a different customer segment. So based on historical transactions, age, gender, several things, the payment channel, what has it been cash or has it been credit card, has it been using Paytm. It does a lot of analytics and then divides its customer into different segments and run different promotions for different customer segments. Very popular, again in a B2C scenario. On a different dimension, people use segmentation for products as well. Let's say a company like Unilever, Procter and Gamble, for that matter, even Patanjali. If they have so many products which they are selling, how do they segment their products so that if they have to launch some promotions or start some distribution channel, which product should they target? For that, they should have segmented their products. That's very popular. Again, let me keep moving fast. Market mix modeling. I spend a lot on advertisement. Which channel should I spend more? I spend on television, radio, print media, Facebook, Twitter, Google search. I have a $1 million for advertisement every quarter, and I have been historically spending so much for each channel. Can you tell me which channel gave me more responses and more business so that I could optimize my spending? This is called market mix models. Where should I focus my spending on? Where should I target my discount? How do we optimize my AdWords? Let's move to the right. On sales, I get a lot of inquiries every day. I am someone who is selling products, and every day I receive thousands of inquiries asking for some invoice, and I keep sending. But only some of them convert as my customers. So which customer should I focus on? Which customer should I follow up so that I could make quick money out of them? How do I prioritize my leads? Which could again be done using data science. Based on historical leads to business conversions, I can teach a system which could score every inquiry which I get and then say, hey, this inquiry is likely to convert to a business and this inquiry is more likely to not continue as convert as a business. How do you prioritize my leads? From a manufacturing setup and a logistic setup, demand forecasting extremely important. Say Maruti Alto is the highest selling car in India. Maruti should be able to forecast the demand for Alto at least for the next 4 quarters because it has to scale up its manufacturing, scale up the ancillary units, it has to do the procurement, it has to do the budgeting, it has to plan its resources. So demand forecasting is an important data science use case, generally done using time series analysis. In financial world, credit risk and fraud detection is one of the most popular use cases. Credit risk, if someone is applying for credit card or a loan, is he a good credit or a bad credit? If I have to give a loan, should I give a loan at all? That is question number one. If I have to give a loan, how much can I give? And if I am ready to give, at what interest rate should I give? All these are decided based on machine learning models. And fraud detection, if someone, because in US, you just swipe the card, there is this chip-based, pin-based verification is not so popular yet in US. And there you just swipe the card. How do we detect if the transaction is fraudulent or a valid transaction. Based on historical transactions of my customer, I'll teach my system saying, okay, these are the patterns of a valid transaction. If you see a transaction which is not following such a pattern, then raise an alarm. So this is fraud detection. Used in customer support, human resources. There is plenty of application for data science. Let me keep moving fast. By verticals, healthcare, consumer financial, retail, CPG, insurance, hospitality services, life sciences. I could not think of any business which don't use data analytics. That's the current state. There is not even a single industry which do not use data analytics and data science. That's the spread which it has got, and people have started seeing business value out of using data analytics. Okay, if I have to do all those things, we saw a lot of data science use case applications. If I have to do all those things, I need some statistical and mathematical algorithms to do that. So let's look at what are the most popular machine learning concepts. The first being regression, trying to establish relationship between two variables. Regression technique was initially coined by the scientist, and the experiment which he was trying to do was very interesting. He was trying to build relationship between height of fathers and sons. So he had a sample of fathers and sons, and he had a record of the height of father and height of the sons. So he had this record, and what he was trying to do is, if I can build a relationship between the height of father and height of son, then in future if someone comes to me, someone who is expecting a baby comes to me and then say, hey, this is my height, can you tell me how much height my son will grow? Then based on a relationship on history, I can actually predict what is going to be the height of his son who is not even born yet. So I can go to the scientist and then say, this is my current height. If I have a son, what will be his height? Based on historical relationship, I can actually predict the height of the son. You have a similar example here. The relationship between weight and height. If the weight of the person is so much in pounds, what is the approximate height of that person? Based on historical data, I can build a model. Many times you will be troubled by this word model. People say, I have built a model, data science model. Data science model is not rocket science. It could be as simple as a line equation. So what is this? This is a line equation, y is equal to mx plus c. A data science model is a simple mathematical relationship. It is not too complicated. Here what we have done is, we have built height. Height is a function of weight plus a constant. We have just built a line equation. How do you build a line equation? That's why we use regression, and there are some techniques like partial least square algorithm, etc., which are used to build this line equation. Let's look at another business example. Relationship between sales versus ad spend. Historically, I would have spent so much for advertisement, and I would have got so much sales return out of those advertisements. If I know those historical relationship, all these are these dots, and I can build a model. That's the blue line. What's the advantage of building this model? In future, if I decide to spend, let's say, $0.55 million, even before going live, I can actually predict what will be the expected sales. I could say, okay, if I'm going to spend $0.55 million, I can expect a $1.1 million outcome. So even without running live, based on historical relationship and the model built on it, I can predict what will be the expected sales for an advertisement spend, which I have not done in the past. I could do for all unknown advertisements. Even for an advertisement which I have never tried so much scale, I can know what is going to be the expected advertisement spend. Regression is the most widely used machine learning algorithm, the most popular one. If someone claims as a data scientist, they are expected to know at least regression to a reasonable comfort. I'll keep moving. Anyone has question, you can interrupt me at any point in time. The next concept is classification. In regression, what we did was predicting some continuous numbers like height, advertisement spend, sales. All these are continuous numbers. I was predicting a continuous number. What if I have to just do a classification? If an email comes, I just wanted to classify whether the email is a spam, or is it from a social media, or is it an important update, or is it is it a note from a friend. Google is actually doing this classification. Google is automatically binning and classifying your emails into multiple categories like spam, social, primary, update, etc. So it's a clear classification. Someone applies for a credit card. Is it a good credit or a bad credit? Just two classes. Whether it is an apple or an orange or a pomegranate. These are all classification problems where you don't really predict a number, but you predict a class. There are a lot of classification algorithms which try to achieve this. One such classification algorithm is a decision tree. If we have time at the end of the session, we will be actually building a decision tree model ourselves. So it says, okay, if this satisfies yes, then take a classification path like this. No, then take a classification path. Then another check, then take a different classification path. So a computer can actually build rules like this and classify for. This is classification, a whole lot of algorithms. Again, one of the most popular machine learning technique. Next come clustering. I was telling you examples of customer segmentation, product segmentation. They are all achieved using clustering. Clustering is different from classification because classification there is always a target. You wanted to classify between a spam email versus a social media email versus an update email, or you want to classify whether it is a good credit or a bad credit. You always have a target in mind. You wanted to classify certain things based on a target. If you don't have a target, you just wanted to group identical things together. Then comes clustering. It is also called as unsupervised classification because there is no target. You are just grouping homogeneous looking observations. Let's look at this. We have three metrics: education, income, and age. You are measuring several people on these three metrics: income, education, and age. And I can actually group people. One group of people who are earning high income, low to moderate education. Another group, moderate to high education, low to moderate income. Here, low education, low income, low moderate income, young, moderate education, low income, middle age. This kind of clustering is used in several business applications. As I told, I gave Uber example. CPG companies with several products in their portfolio, they do product segmentation. Policymakers, if Narendra Modi would like to launch 3 new schemes and he wanted to do it in different districts of India. So if he might ask a data scientist saying, okay, hey, can you group the Indian districts into homogeneous segments so that I can decide certain policies for each group. So I could have Dharmaburi, some remote district in Hubli, something in Assam, something in Gujarat, something in Rajasthan, all coming into one group. While they are geographically split, from a demographic standpoint, they could all come together. Chennai, Bangalore, Hyderabad, Kolkata, Delhi, they may all come into one group. So the entire India could be segmented into different groups, and Narendra Modi can take a different policy decision for each group. Very powerful, and there are again several clustering algorithms which are used to achieve this kind of a segmentation. Time series analysis. I was giving you the Maruti Alto example. This has been my historical sales. My sales generally peaks during November, December, and comes down in January, February, and it slowly increases in quarter 2, quarter 3, and it peaks in quarter 4. Again, it comes down. And my sales has been generally increasing. It has been generally increasing. Having given a pattern like this, based on historical data, can I forecast for future? Looking at the historical pattern in my sales, can I forecast what is the future is going to look like? A whole lot of time series algorithms. Again, those algorithms have been there in the statistics world for several decades, but they are getting popular. ARIMA, Holt-Winters, very being used left and right in for business purposes in the present past. This is time series analysis. And another popular technique, reasonably involved from a mathematics standpoint, but the larger goal is I have a lot of dimensions. I want to reduce the dimension. For example, if someone applies for a loan, the moment the person gives their social security number, I can put so much information, their driving behaviors, their historical accidents, their health related data, historical credit behaviors, how many times they did not pay the due. I could get thousand things about a person moment they give their social security number. But how do I? It's too much for me to visualize the data. It is too much for me to even build a model. So I need to take juice out of it. If I have a fruit has a skin, fruit has seeds, I just want the portions which I need for extracting the juice. So that kind of a juice extractor is algorithms like principal component analysis, which are used for dimensionality reduction. I know thousand things about a person. How can I compress and extract only things which are of use to me? That's where a whole lot of dimensionality reduction techniques like principal component analysis, linear discriminant analysis, etc. come into picture. Okay, the last one being text analytics. Whatever we have been seeing so far, all examples were on numerics, and all machine learning algorithms are written only for handling numbers. Machine learning, statistics, mathematics, everything is for number crunching. Nothing is written for non-numbers. Everything is for numbers. But what we do today is type in WhatsApp, post in Facebook, check in Twitter. We do a lot in text. Our world is full of text. We are speaking very little and texting a lot more, which means how do I process this text, because they are not numbers, but all these machine learning algorithms are working for numbers, but how do I do some analytics on text data? That's why text analytics is a different branch in data science, where these texts are converted to some meaningful numbers. It's called feature engineering from text. And on that, I can do my machine learning algorithms. And what can I do? I can do sentiment analysis. Let's say if Apple is launching its new phone, it can sense the sentiment of the customers by watching all the social media, Facebook, Twitter, Instagram, Tumblr, whatever it is. It can sense the sentiment. Or if a company has launched its mobile and has been there for 6 months, it would like to see what has been the post related to. Is it more about service issue? Is it about heating issue? Or was the sales channel right? Was it delivered on time? Were there too many returns? Or are they generally speaking about some feature defect on fingerprint recognition? I could do all this kind of text clustering by watching the social media. Text analytics is a branch by itself. If someone says data science, it could be just either of these three. It could be any data science problem could be solved with either regression, classification, clustering, time series analysis, dimensionality reduction, and text analytics. While it looks like an ocean, it finally boils down to 6 large machine learning concepts. So if someone masters these 6 concepts and know couple of algorithms within each of these concepts and is able to run such algorithms in a tool like R, then they could claim themselves to be a data scientist. So It's all simple. One needs just focus, cut out the noise, and understand that it is not a complicated world. It is a simple world with just six concepts. And all these algorithms are already pre-implemented in languages like R. What I need to know is understand these concepts. Under each of these concepts, there are several hundred of algorithms. I should not try to understand everything. Let me understand the most popular ones, get my hands dirty on those algorithms by using languages like R, and get experience from this. So that should be a path which someone should take on understanding machine learning. Okay, having said all these things, why R? What's the power of R in machine learning? The first point being R is free, because machine learning again, it's not started only from R times. MATLAB was there for a while. Even before R, there is a language called S. So there had been a lot of machine learning and statistics tools in the past. Even SAS is a tool which can do machine learning. But all these are licensed proprietary softwares. You may have to spend a lot for procuring the license, and proprietary, which means if that company do not build a particular feature, you don't have it. But R is a free tool, which means you don't need to pay for a license. And it is very simple to use. It's not very complicated. 8,000 plus packages, all available free of cost. You don't need to pay for anything. You just need to download, like even in your Android mobile, you have paid apps and free apps. But in R, there is no concept of a paid app. All the packages which are available are free of cost, and it is not hard to integrate them. You can just install, and all these packages play nicely together. You don't need to go through a challenging installation path to get into things working. Things just play nicely together. A lot of packages for data access, data cleaning, building models, visualization. 8,000 plus packages. There is no other statistical programming language which has a plethora of packages. Every PhD thesis, this I have been seeing, watching this as a trend across several universities. Anyone who comes out with a PhD research on a machine learning topic, their final outcomes is generally an R package. Whatever new algorithm they have come up with, they try to generate an R package out of it. Even the most remote, the most niche machine learning algorithm which you are looking for, you referred a paper somewhere which has some new machine learning algorithm invented, you will highly likely see a package for that in R and not in any other language. That's the power of R. And having said all this, this free and it's also open source, which means you have access to the source code of the R as well as the entire packages. So is it hard to program? Should I do it in a black screen? Should I do it in a notepad? Should I do it in a VA editor? Is it hard to program? No. There are very good IDEs like RStudio. RStudio is like the most popular integrated development environment for R, which is used by almost 99% of R users. Very nice IDE, a lot of interactive features. You don't need to sweat out and struggle hard to program. Most of the stuffs are sophisticated, and your life as a programmer is very easy when you have an IDE like RStudio. And amazing ecosystem of developers. As I told, in a proprietary language, if you want a new algorithm or a feature to be implemented, you need to wait for them to get enough customer traction for that and release, etc. But here it is all driven by developers. As long as there are enough developers who are ready to do this, they will just do. Or if you want to develop, you can develop and release a package. A great ecosystem of developers working across the clock, because the presence is there across the globe, and so much happening around the R world. What are the features in R? This is the most popular tool for data science and machine learning, because it is exclusive for data science and machine learning and the most popular one. And it is OS independent. It's not like it will run in Windows and not in Linux. No, you can write an R script. It will run in Mac. It will run in Linux. It will run in Windows. It will even run in a PlayStation. So that's the level of OS independence it has. Very lean as the software is concerned. You don't need a 16 gigabytes RAM, 1 terabyte hard disk to install R into. People work with even a 2 gigabytes RAM and a very minimal memory left over in their hard disk, and they are comfortably running their browsers, having a music player running, and R also running in parallel. Very lightweight software compared to other proprietary tools like MATLAB, SAS for that matter, which are considered to be heavy softwares. R is quite lean and very modularized, so that if you want to do something simple, you don't need to load your machine and things will run without any hassle. And another question which you generally get to answer is, do I need to be a programmer to learn R? No. R could be your first programming language because it's very simple and you need not have any programming experience. You can slowly start become like a user. Like if someone uses Excel, they just do some drag and drop, do some things. They are not programmers. So you can start like a user and then slowly evolve as a programmer. Finally, you have to be a programmer because R being a programming language, if you want to claim that you are strong in R, you have to be an R programmer. So your end goal should be becoming an R programmer. But for you to achieve that goal, you need not be a programmer to start with. R could be your first programming language, and you can still become a strong R programmer at the end of a focused training. As I told, it's free of cost. You can use R for any purpose. You have access to the source code. You have the freedom to redistribute copies, and you also have freedom to improve and contribute to the program. So a lot of freedom surrounding R. Okay, what's the history of R? It was announced in early 90s, and it was announced, actually it was the initial developers were from New Zealand, Robert and Ross. That's why the name R. The first letters of Robert and Ross, they were the first developers who announced R public. Later an R core group for formed, which is a not-for-profit organization. The first version of R was released in 2000, and significant bug fixes releases which happened, and now we are, I don't know, there might be an update beyond this. As far as I know, the latest release was R 3.4.1. So many features, so many bug fixes which is happening over time, that there is a release definitely once in a quarter. Once in 3 months, you are bound to see a new release of R with a lot more features and a lot more bugs fixed. Very active development going on in the R. Okay, let me complete this presentation and move to the hands-on with this final note. We, as I told, we do data science training as well as consultation. And what do we train? When someone chooses the R track, we make them perfect in R programming. Start with the fundamentals of what are the data types in R, how to slice and dice data in R. How do you do control instructions? Because anyone who claims to be a programmer of a language is bound to know control instructions. So how do you write control instructions in R? How do you process data in an optimized manner? Because anyone can process data, but how do you process in an optimized manner using some optimized functions in R? That's one of the chapters. How do I read external files, process it? How do I write my output as a file? That's all covered in file processing. And finally, visualization. Any data scientist should also be able to tell story out of data. For that person should be capable of visualizing the data. How do you do visualizing using R? So with R, you can do the complete spectrum of data analytics, right? From reading the data, slicing and dicing, doing some processing in an optimized manner, visualizing, and etc. could be done using R. So these are covered. Then comes machine learning. As I told, there are these 6 popular topics, and all 6 are covered in the machine learning track. In regression, we do see all linear, non-linear, multiple linear regression. Clustering, the most popular k-means clustering. Classification, k-nearest neighbor, naive Bayes, decision tree, random forest. Dimensionality reduction, principal component analysis, linear discriminant analysis. Time series, ARIMA, Holt-Winters. Text analytics, different feature engineering like Darkman term matrix, inverse Darkman frequency matrix, and doing sentiment analysis, document clustering. We do all those things in text analytics. That's the outline of the training which we generally do. These trainings together, this goes for around 25 to 30 hours of classroom session and an associated assignments which has to be solved, which would again take 30 hours of time. Overall 60 hours of time which one dedicates for this particular course. And machine learning similarly, it's all hands-on, which means someone builds model in the class with one use case data, and there will be assignment on another use case data. Again, 50 to 60 hours of time which someone has to spend for this particular course. Okay, that's it from my side on the presentation. The next plan would be to do something hands-on in R together. Any questions? This is turning out to be generally a silent audience because I do such sessions once in 2 weeks. This is turning out to be the most silent group which I've ever interacted with. So I'm going to have a long pause and wait for almost everyone to speak out. Niranjan.
We are good, Karthik.
Okay, great. May I know who spoke? Sundar?
Sundar, yeah.
Okay, thanks, Sundar. Niranjan, all good? Any question?
Just a small query. I thought of asking it at the end of this session, but I thought I'll just put it out to you. It's up to you whether you want to answer it now or later. So, in general, I'm from a totally different domain, and I'm just out of curiosity. I'm learning machine learning and R of late. But from an expert perspective like yours, I just wanted to know what would you advise? Whether Python or R for a beginner, because there are both job metrics and also how robust is the language. From the slides, I see that. Obviously, R has a lot of packages and other things that would actually have an edge. But on the statistics side, Python has a slight edge, I guess. On both the job metrics and also the usability perspective. But for a first timer like me, what would you advise? Because I don't want to sail in both the boats, and I'm not sure whether that would also be feasible for someone.
Okay.
So, what would you advise for a first timer like me?
Okay. Good question, Niranjan. And it is one of the classic debates which I encounter. As I told, I myself train in R as well as Python. Both are same to me. And I know both the words and I don't carry a bias. So I will give my viewpoint. Let me start. I will come to your beginner question in a couple of minutes. General, from a job description standpoint, if you look at any job description, you could see this word R and or Python. So it will be good if someone knows both or at least one of them. So from a job description standpoint, you can get the work done either using R or Python because they are quite comparable from their features, the ease of programming. So ease of programming wise as well, R and Python are comparable. I would say R is a small epsilon easier than Python. Not a big drastic difference, but I've generally got this feedback from my students that because I've had a lot of students who have taken both R as well as Python. Some people who have started with Python came to R, some who started with R and went to Python. And I have seen some feedback saying, okay, I find R to be little easier than Python. That's a feedback from them, but from a syntax standpoint, they are quite comparable. So if someone is starting as first, both are a good starting point to do. Someone is a bit scared of programming, maybe R is a good place to start for a simple reason that R is focused on data analytics and machine learning. It doesn't know anything else, which means everything you see in the web, every help you see, everything you do will be surrounding data analytics. If someone wants to be in the data analytics career path, then or if they want to start with something, then I would advise R because R is quite focused on that. Python is the most popular programming language according to a survey in 2016, even beyond C++ and Java. Python is a general purpose programming language like C++, Java. You can do automated testing using Python. You can do application development using Python, web development using Python, some other automation script using Python. You can also do data science using Python. Python is like a Swiss knife. You can do multiple things with Python, and that's the reason there is a big group also liking Python, because if I am unable to get into a data analytics career path, if I know Python, I can at least become a Python developer and slowly move towards that, become strong in Python. And since Python also has data science capabilities, I can get into the career path sooner or later. So Python gives you a wider window to play around. Someone who is already a software developer in C++, Java, they may not probably get an opening in data analytics immediately because they may not have relevant experience. So they would like to gain experience at least in Python, if not for doing data analytics, and become a Python developer and slowly orient towards data analytics. So that is a preferred career path for someone who is already from an IT background and would like to slowly move towards data analytics, where Python is the next jump from their traditional development of C++, Java, or even people from a testing background or any other background. So that's the path with Python. R has an advantage over Python in the availability of machine learning packages. As I told, 8,000 plus packages, that is huge. Having said that, most of the popular algorithms are implemented both in R as well as Python. While there are thousands of algorithms, only 10 algorithms are the most widely used, and they are implemented in a very robust manner in both R as well as Python. So if someone wants to do data science, they can pretty much use either of these languages and get almost everything done. Python has an advantage over R in a way that it can speak with big data ecosystem like Spark. R of course can also speak with R Spark. Python has Python Spark. Python can speak with JavaScript quite easily than R. So there are a lot of Django, JavaScript, Flask JS, a lot of JavaScript web front end which speaks with Python at the backend. So from a productionized data science development standpoint, Python has a slight edge over R. Both going tight hand in hand. At some point in time, someone should know both. If someone wants to be a successful data scientist, they have to know both because each of them have their own advantages on certain steps. But from a starting point, if someone is starting fresh, don't want to be worried about so many things and don't want to get confused on, because if you start Python, which IDE to choose itself is a debate. There is PyCharm, there is Spider, there is Eclipse, there is NetBeans. You can do almost all IDEs for Python. And Python 2.7 or 3.5, there are a lot of conflicts between versions. How do I install? Should I use a plain Python or an Anaconda Python? There is so much in plate, and someone could get lost in that process while learning Python. R, very clear, very focused, not much confusion. You have a focus on data analytics and go. So a beginner, I would prefer R over Python. A long answer for a short question, Niranjan. Did that answer?
No, that makes sense. I mean, thanks so much for shedding some light.
Okay, great.
Karthik, that's actually a very good answer. If may I add, Niranjan, one more thing is, like Karthik said, at some point you may want to know both Python and R, and there are libraries out there where you can actually invoke a Python code in R, and you can do the vice versa. And even proprietary softwares these days, they have functions that can call Python or R libraries in their program. So a proprietary program like Jump, they allow Jump or Tableau, they allow R code to be called within their proprietary code so that they can perform statistical analysis. But the one-liner would be Python is for all programming needs, and R is particularly tailored for statistical applications, so which plays nice for data science.
Okay, thanks Sundar for adding on that. Any questions, Jayanti, Sudha?
No, I'm fine.
Okay, good. Okay, let's move on to do something hands-on. Out of this group, let's do something interactive for a while, maybe some time. How many of you have R Studio or R Studio installed in your laptop? Maybe you can speak out or you can type in the chat window.
I have, I think, both RStudio and Anaconda.
Okay, let's stick to R Studio Niranjan facts. I believe Sundar should have. Jayanti, do you have it installed?
Yeah, I have JMPR and Tableau.
I have JMP. I have JMP.
Okay. What's that? I don't know what is JMP.
It's one of the SaaS. It's one of the statistical.
Yeah, it's for
tools from
SaaS, right? It's a SaaS.
Yeah.
Don't
Yeah.
R
Yeah.
installed, Jayanti?
Sorry?
Don't you have R installed?
So I have a version, but that is for my office. So we use it for our office.
Okay,
Yeah.
no problem. Okay, so whoever has it, let's get started and do some warm up. Whoever already knows R, let's still do this and get our hands dirty on R. We'll do a warm up. I'm going to share my is my R Studio coming up?
Yes.
Okay. Let's do something simple. So let's create a function in R which will detect whether a number is prime or not. So what's the logic to identify whether a number is prime or not? What's a prime number? That's a strange silence. I thought it's a classic interview question.
Oh no, we didn't know you were asking a question or you're saying something.
I was asking a question saying, how do we know whether a number is prime or not?
But it has to be divisible by just itself and 1.
Okay, so a number which is divisible by itself and 1 is prime, or to put it other way, a number which is not divisible by numbers other than itself and 1 is a prime number. Okay, so to know a number is divisible or not, we divide it and see if there is a remainder. If remainder is 0, then it is divisible. So 3 modulo 2, modulo operation is for double modulo. So 3 modulo 2 is 1, which means it is not divisible by 2. 4 modulo 2 is 0, which means 4 is divisible by 2. We know 7 is a prime number because 7 is divisible by 1. Seven is divisible by 7, but 7 is not divisible by anything. 2, 3, 4, so on and so forth. I could always see a remainder when I divide. Is 117 a prime number?
We don't know.
Okay, so yes, so it's hard. We need to try with different options and then do. Let's see how to do this in R. I'm going to write a function. So this is how you write a function. That's the keyword for function, and I'm going to write a function saying is prime. It's my own function to which I'll be passing some number. And I'm going to try dividing this number starting from 2 till the number before this number, and if any point in time the number is divisible, then I am going to say this number is not a prime number. What I am going to do, I am going to loop, I am going to write a for loop, which starts from 2 and goes till the number -1 and says if the number modulo I is equal to 0, which means it's divisible. I'm saying print not a prime number, and I'm going to break out of the, let's say it. When I run this goes and saves as a function in R. As you see in the right, it's a function. Now I can call this function with different numbers. Let me use something simple. This prime it's prime of 7. I don't see anything printed, which means it's a prime number. Let's look at 117. Oh, say it's not a prime number. So now I'm curious to know which number was dividing it. Let me also print not a prime number. Print of I. Which one? Oh, it's divisible by 3. So 117 modulo 3 is 0. It is divisible by. Let me look at 119. It's also not a prime number. It is divisible by 7. So we've written a small snippet without much of a hassle. You did not do int I is equal to something, float something is equal to something, doing a memory allocation. You don't know all these things. You have a logic in mind and you are able to do this exercise so easily. Any question on this? Or anyone wants to do some more fine tuning to this? Okay. If not, let's do something interesting. I'm going to share a link in the chat window and would request you to go to that URL. Let's do a search. Let's do UCI machine learning repository. This is a place where a lot of open source data is given, and let's search for something called Pima Indian data. So data of Native American Indians, data related to their diabetes. Let me share this link. So what is this data all about? It has information of Pima Indian female, information like number of times pregnant, plasma glucose concentration in a 2-hour test, diastolic blood pressure, triceps, 2-hour serum insulin, body mass index, diabetes pedigree, and finally a class variable. It says whether the person is diabetic or not. So this is a classification problem. So you have data of how many people? So you have data of 716 Pima Indian female, 8 attributes measured, and what you could do is a classification technique. Let's get to the data folder, and you have a data. So this is in a comma separated format. Each one is a column. First is having 6, which is number of times pregnant. So this observation, this person was pregnant for 6 times. Plasma glucose concentration 148. Diastolic blood pressure is 72, so on and so forth, and last being 1. So this person is diagnosed as diabetic. Let's try reading this data in R. We can directly read this data in R. This is a comma separated values file, and there are commands to read comma separated values. I'm going back to my R screen. So this is the URL. Let me read it as Pima Indian data is equal to read.csv and give this whole path. And if you want to know help of this particular command, I can go to help, see read.csv. So you can give the file. By default, header is true, but in this case you would have seen that there was no column headings, so I'm going to add an argument saying header is equal to false. I think I'm good. Let me run this line. I have this data bingo in my RStudio, 768 observations and 9 variables. I'm going to copy this command and paste it in the chat window. Whoever has RStudio open, I request you to run it in your laptop and let me know if the data is loaded. What we are going to do is we are actually going to build a decision tree classifier for this data. So let's load the data first in our systems. Once it's done, you can let me know, and we could proceed once all of you or whoever has RStudio is installed have the data loaded.
Yes, Karthik.
Okay, thanks. Check with Niranjan, are you attempting to do it?
Yes,
Okay.
Karthik, I'm just doing.
Yeah.
Give me a moment.
Yeah.
Yes, I was able to load it.
Okay, great. We are going to follow a classic data analytics value chain, which someone would do. We'll not get into in depth of many things, but we'll do. First thing is data reading or loading, which is done. Next is data exploration. As a part of reading and loading prepping, one of the key things which one has to do is the column names. As we see here, the column names are not very intuitive. It's V1, V2, V3 because the raw data did not have the column information. It just had, if you go to the Pima Indian website, you could see that it just had the data as such, but the column names was given in a different. I'm just trying to share my screen. But in one of the tabs, actually, it had the information of each of these columns. In the interest of time, I have actually typed it out, and I would copy it here in my window. Adding column names to the data frame. It's the number of times pregnant, plasma glucose interact, the concentration, diastolic blood pressure, so on and so forth. I'm adding this information. So as you could see, now you have something meaningful. Let me also paste this in chat window for those who are following. Okay. Having done this, the first thing one tries to do is doing a statistical summary of the data. That's done using a command called summary. It gives the statistical summary. For instance, number of times pregnant. There could be observations with as low as 0 times pregnant. There are observations with as high as 17 times pregnant. The mean being 3.8 and median being 3. So on an average, 3 times pregnant is the average number of times pregnant for the Pima Indian female population. If I could look at age, minimum of 21 to maximum of 81. So you have data of a complete spectrum of population as low as age of 21 to as low as high as 81. An average around centering around 33. Something is jarring here. Diastolic blood pressure, we know that it cannot go 0 for any human being. Even glucose concentration for that matter, it can't go 0. Body mass index, again it can't 0, which means something is wrong with the data. It's not a very clean data. And it is also mentioned in the website, as you could see. Update. This web page indicated that there are no missing values in the dataset. As pointed out by a repository user, this cannot be true. There are zeros in place where they are biologically impossible, such as blood pressure attribute. It seems very likely that 0 values encode missing data, which means there are some missing data, which means it has to be handled before we doing any kind of an operation. There are several techniques to do handle missing values. One of the techniques, which is the most simple, being removing data with such missing values. We will remove observations which have such observations. Let me do that. We are going to hunt for those zeros in such columns, and I have to move back to my RStudio. One such option, as I told, is hunt for the zeros, but we can't do it for all columns because number of times pregnant 0 is it's an acceptable number, but in other cases it's not. Class column, again 0 is acceptable because as we saw, 0 is non-diabetic and 1 is diabetic. So in that column also 0 is a permissible number. In other columns it looks like 0, it's all indicating missing value. So I'm going to hunt for zeros in the other columns and do this. So in the interest of time, I am going to paste pre-implemented code. So what am I doing? In columns 2 to 7, those are the columns where zeros are not possible. Plasma glucose 2, 3, 4, 5, 6, 7. These 7 columns, a value 0 is biologically not possible. So I am hunting for those columns. I am extracting them in this line. And I am filling 0 with NAs. Let me open the data frame. So you will see NAs wherever it is 0. Wherever it is 0, it has NAs. And I have a command to merge back the first and last column because I extracted out the first and last column because 0 were valid numbers here. I am putting them back here and running a command which will remove observations. Complete.cases is a command which will remove observations which has NAs in even one of the columns. Let me run all of this, and what I am getting out is a Thema data clean. So from 768 observations, we have come down to 392 observations, but all clean data. If I now do a summary of Thema data clean, I could see all having some value. Plasma glucose constant 56, diastolic blood pressure 24, 7, 14. I don't see BMI starting from 18 to 67. Number of times pregnant, we know it could go to 0, it's fine. Age 21, class minimum 0, that's also valid. So we have, what we have done is, we have cleaned the data. We have removed observations which had zeros in some unacceptable columns. I have again pasted the commands. Maybe I will give a pass till whoever is following copies the code and make sure they have also got a clean data. If someone faces an error, can let me know. I can make you share the screen and debug live. Is it running or even facing an issue?
I was able to clean it up.
Sorry, Niranjan?
I was able to clean it up.
Okay. So you also see the clean data, right?
Yes. Okay. Yes. In the summary, I'm able to see it.
Okay. Sundar, are you trying by any chance, or should we proceed? Okay, let's go ahead. Okay, having gotten a clean data, what we are going to do is actually build a classification model. So what is this classification model for? We are going to predict the class. So a variable which we are going to predict is called a dependent variable. Dependent variable is the class in this particular data. Independent variables are others. Independent variables are the variables which are used to predict your dependent variable. So any classification problem, you need to list down the dependent variables and independent variables. Building a model is actually very easy. I am going to build a decision tree model. It's one of the most popular classification technique. To build it, I am going to invoke a package called rpart. In case you don't have it installed, it's quite easy to install. You can go to install packages. In packages, type rpart and install. Niranjan, do you have it installed by any chance? If not, can you try installing? It will take less than a minute to install.
Okay.
Install Niranjan.
Just a moment. Okay, I just got a message telling that one or more of the packages that will be updated by this installation are currently loaded. So does it mean, I may already have it?
Okay. I will make you the presenter. Can you try sharing your screen?
Sure. Sure. Are you able to see my screen?
Yes. That will be updated or currently loaded. Restarting R prior to this strongly restart R prior to. Go ahead and click yes. Okay, R part successfully installed. Can you do a library of rpart library library in the code? Yeah, library bracket rpart. Yes. Great. Warning is fine. So it's loaded. Building model is easy. Let's build a tree model. Current diabetes tree. I'm going to call a function in this package, and the function name is also rpart, to which I have to pass the dependent variable and independent variable. In this case, class is the dependent variable which I want to predict. So I'm going to say class tilt, and I'm saying all other data, all other columns are my independent variables. I'm going to use all these variables to predict whether someone is diabetic or not. So I'm going to just put a dot, which means all other variables. I don't need to mention them one after. Let's see, data is equal to Pima data Okay, so I'm doing this processing on the PMR data clean, and I'm drawing a classification model. So I'm saying method is equal to class. Okay, run this. Done. Great. For me to visualize this output, I'm going to load another package called rpar.plot. It's one of the most popular packages for visualizing tree models. It has a function called fancy r rpar.plot. Or it's part of Rattle. Yeah, maybe it's part of Rattle. That's a different package.
So is it from a different package?
Yeah, fancy rplot. It's from a package called Rattle. You can install that as well. If you go to packages, install, you will see Rattle. That has some good visualization tools for viewing decision trees. Once you install, you can load it. We can do that later. I will be emailing the script if needed. So this is the decision tree. It's so much of depth. There is a parameter for decision tree which decides the depth. One can always look at it in detail while going through the course. As of now, let me fix the max depth to four levels. Nice. So what it has done is it has actually built some rules saying out of the 100% population, the first thing which I look for is whether the plasma glucose concentration is less than 128 or greater than or equal to 120. That's the first cut. If someone has a glucose concentration less, then there is a high likelihood for them to be non-diabetic. And someone has more, then I have to do some more test. Then I do further check on again plasma glucose concentration and says if it is more than 166, then it is highly likely that the person is diabetic. Even though it is between 128 to 166, which is this branch, if the age is more, then there is a chance for being diabetic. Age is less, then maybe they will be non-diabetic. Let's take this branch. The plasma glucose concentration is less, but if serum insulin is more, then they come here. And if age is also high, if age is above 28, then there is a high likelihood for the person to be diabetic. So a person with a high plasma glucose concentration and on the higher age, there is a high probability for them to be of diabetic. And even those with low plasma glucose concentration, with a high serum insulin and the higher age, there is a large probability of being a diabetic patient. So I could build a rule automatically using decision tree, and having built a model like this, one can actually predict for new data. If I get some new patients information, even without doing a whole lot of tests, with only the plasma glucose concentration and serum insulin values and information about age, etc., which is already available, I could pretty much diagnose whether a person is diabetic or not. I don't need to prescribe a lot of diagnostic tests. With couple of tests and other information about age, body mass index, etc., I can pretty much predict whether the person is diabetic or not. Decision tree, one of the most popular techniques. There are a lot more sophistications done in classification, but I believe this is a good place to start with Niranjan, I'm uh, pasting it in the chat window for your quick reference. I know we are overshot by 15 minutes. Does anyone here, we are done with the session. As I told, the larger intent of the session was to give an overview of what is data science, machine learning, why R, and do something hands-on in R so that we do some warm-up. So that's the agenda, and we are done. Any question on anyone in the line?
Karthik, are you going to share this R code?
Yes, I can.
Thank you.
Any other questions? Niranjan, are we good?
I was just trying to type it on my phone.
Yeah, please. I will wait, Niranjan, till it gets work. But you may have to install Rattle.
I did.
Okay. Since you are trying out, Niranjan, let me have take a look at your screen as you type in. Can you share your screen?
Sure.
I think it should work. A formula argument is required. Oh, you see, you have a comma before class. Can you type it out, Niranjan? Maybe whatever, paste it in go to meeting something. It's the tilt, class tilt. It's not equal to. It's the tilt operation above tab in my keyboard. Yeah, exactly. Class tilt dot. Yeah, wonderful. So the model is built. Now you may have to install the Rattle package.
Yeah, I think it is already
Done. Okay, then you can do a library of Rattle.
Can you repeat that?
Library of LN.
Yeah, loading the Rattle library is giving me some DLL missing error and giving me options to install something else. So.
Oh, okay. So yeah, what happens is that might have some dependencies which
Yeah,
may
that's
have.
what it looks like.
Yeah, you may have to install the dependencies and it works. Okay.
Okay.
What dependencies is it showing, Sundar?
I guess it's GTK
Okay.
or GTK2.
Okay. Can you search for that package and install it and then try installing Rattle again?
Yeah,
Or you may have to just do a library again. Failed to load MDTK to dynamically attempt to install it. Can you search for MDTK to install packages? Packages install. Niranjan, in install, click install in packages. Niranjan, there is no package called R color brewer. You may have to install them, the dependencies, Niranjan. Can you go to install? Click install and copy this.
Okay, because the GTK one, I think I installed it.
Let's see, I think there are a lot of dependencies and the installations of dependencies did not probably go through well. I think it's asking for R color brewer. Let's try that first.
Okay.
Yeah. Okay, now let's run the fancy R part. Let's see if there is any other dependency. R part dot plot. Okay, let's go and install that. Install, you may have to click install. Install R part dot plot. Done. Now do the library. Let's see if there is anything else left. No, no, you run the line 28. It will automatically load. Niranjan. Fancy R plot has a dependency with R bar plot, so it will load for you. What you may have to run is line 28. Yeah. Super. Nice. Pretty much the same. Sundar, do you need help or is it in practice?
It's okay, Karthik. I guess I'm installing the dependencies. I'll figure it out later.
Okay, great. I will email the script. Okay. Any question, Niranjan? Since you tried hands-on.
No.
Okay. Okay, great. Raghu, would you like to add something?
Yes, Karthik. Guys, I'll reach out individually to each one to get feedback about the session, and also like how we can connect together, like how we can coordinate to meet your training requirements, or help in learning machine learning in R. So I'll reach out to you individually, and also we will share these recordings. Yeah. So, and also I'll be forwarding the link where you can review about mesh analytics, about the training session today. So that will be really helpful for us. Thanks, guys.
Okay. Thanks, Raghu.
Thanks so much, Karthik and Raghu.
Okay.
Yeah.
Thanks, Karthik. Thanks, Raghu.
Yeah. Thanks, Sundar, for making the session interactive. We appreciate it. Thanks, Niranjan, for trying out. Thanks, others, for joining.
Good night, Karthik.
Okay.
Thank you.
Have a great day, everyone. Bye-bye.
Bye.
Thank you.